Number 32, which of the following statements about Kp, the equilibrium constant for the reaction, is correct? So is K greater than 1, less than 1, or equal to 0, or equal to 1? I would have to do some calculations. So let's refer back to the ice chart once again. PCl5 goes to PCl3 plus Cl2. And if we do the ice charts, well, we can kind of figure out what's going to be the equilibrium partial pressure for each one of these gases. Well, in the beginning, we had 1 atmosphere, and we had nothing, and we had nothing. And I lose some, and I gain some, and I gain some. And unlike the previous problem we just did, where the question specifically told us that it went to, if it were to go to completion, well, it really doesn't go to completion. How do you know? Well, because if you refer back to this diagram right here, the total pressure inside the container after the reaction progresses is 1.4 atmosphere, as compared to the answer, which was 2 atmosphere for number 31, if it were to go to completion. So there's that discrepancy of 0.6 atmosphere, meaning it probably didn't go to completion. So we're going to go ahead and use this right here, the given 1.4 atmosphere in total after the reaction reaches equilibrium. So let's go back to this. So that'll be 1 minus x and x and x. Once again, Dalton's law of partial pressure says the total pressure inside the container is the sum of the pressures of all your gases, partial pressure of all your gases. So when you add all these up, so 1 minus x plus x, that is what should equal the total pressure in the figure 2, the equilibrium phase, which is 1.4 right here. So I'm going to set this sum equal to 1.4. So if you guys do that, cancel one of the x's, you can subtract 1 on both sides. X is equal to 0.4. So now that I have that, I can replace the x with 0.4 right here, 0.4 right here, and that would be 1 minus 0.4, which is 0.6. So there you have it. You have all these partial pressures now. So we can now go ahead and set up the K value. So Kp is equal to pressure of PCl3 times pressure of Cl2 all over pressure of PCl5. So if you set it up, that'll be 0.4 times 0.4 all over 0.6. Okay, so I'm going to write it in scientific notations. That'll be 16 times 10 to the negative 2 over 6 times 10 to the negative 1. So if you guys do the math, you can cancel that. So that'll be 8 over 3 times 10 to the negative 1, which is like 2.67 times 10 to the negative 1, which is 0.267, which is less than 1. So there you have it. Answer choice B.